Okay, so I was talking about one exercise problem. Suppose I have a dictionary. I'll just take anything here. Suppose 1, 2 colon. Maybe I'll use some other value. Then 3 colon. I will use some list here. So we can have, by the way, let's say Akash, John. Okay, I just use two elements in the list. Now the fourth is could be a dictionary, okay, which I can probably hold some numbers, or maybe yeah, let's say phone number, okay, and I use some number here, and then I can probably use address, okay, 67 High Street. So yeah, that's something we have added. Moreover, we can also have something more. Let's say 5 colon. I want to use just a string here, right? So that's the another element. I can also have 6 colon. Let's say a list of numbers 4, 5, 6, 7. So this is how we can have a dictionary. Okay. So let's say, let me see how it looks. So this is how my dictionary looks like. Okay, so now suppose I want you to understand how to traverse through the dictionary to get more information, right? Probably I want to get phone number, or I may want to get some particular the address out of this dictionary. So I want to probably traverse in a way that where I will check the inner dictionaries. Okay, so we can do that. How to traverse? First of all, let us traverse through key and value, okay, from in dictionary, that is my dict, and we can see that we can print key and we can print value, right? We are not interested to print, by the way. What went wrong? Cannot unpack. Oh, sorry, I have to do items, correct? Yeah, so key and value we are getting here, right? So now let's understand what we do for the key and value, what we are getting we are getting out of this dictionary. Okay, suppose I want to check is instance, and I want to check the value, right? Whenever I find a value which is a dictionary, okay, I will probably print the value, okay, and look at this. If this is true, then I get a sub dictionary. Remember, we are interested to just get the sub dictionaries, okay, and if you are interested to get the lists, so you will see that there are 2 lists available inside this particular entire dictionary, right? So we can do whatever is the case. So this is how isInstance function is used. Very useful function, and we have already discussed about this earlier. Now once you get the dictionary, so you could also traverse once again for K1 and V1 in the value, right? V is nothing but your dictionary, that is inner dictionary. Now you try to print, okay, K1 and let's say and V1. Okay, so obviously it should not be a quote here. Okay, so let's see what went wrong in v dot items, correct? So I got a phone number and address, right? That is what exactly we were looking for. So this is how we can traverse through the dictionary to any level, right? So if you are going through deep levels, the dictionary may hold other dictionaries. So for example, I will take one example. I just randomly searched some JSON data so that we can use this as a dictionary in our Python code, and let's try and explore how it works. Okay, I use D is a keyword I use. It is actually what is the type of D? Can somebody quickly guess? Okay, so remember, we are creating a list here, right? So this square bracket indicates we are creating a list of dictionaries. Okay, list of dictionaries. There are 3 elements of this list, and we are creating the dictionary. Okay, we are using dictionaries to create a list. Okay, so let's try and check how D looks like. So D looks like this. D is a list. So if I see D of 0, I get a first dictionary, right? That is the first part of your list. This is the first, the selected portion on the screen is the first element of a list. Okay, and this first element is nothing but a dictionary, right? So we may want to explore, we may want to go to the depth, understand what this how to access various dictionaries. So for example, for the values or elements in D, so you can just print element, right? So every time you get one dictionary, this is the one dictionary, this is another dictionary, this is another dictionary, right? So you can perform any particular task on each of these dictionaries. Okay, for example, here for k and value in element. Okay, now you are trying to print the keys and the values, right? And you want to print only key and values where there is a list, one more dictionary in it, right? So for example, if is instance, let's say value is dictionary, okay, then only let's print it. Okay, k comma and value. Okay, and let's try and see what happened. What went wrong? Anything you see? K and value in element dot items. Okay, here you see that foods is the is the key in each of the dictionary, that is a sub dictionary. You will find foods. Okay, and foods has another sub dictionary. So that is what sometimes we may want to use it. So otherwise the species and the name, these are ignored here, because we are interested in just getting, let's say, food, or maybe the dictionary where I find some more information, right? Or you may go further and explore this, for example, for item in let's say the dictionary, right? Whatever is the dictionary you get, and you just print the items, right? So you see that likes and dislikes is printed here. Okay, and in fact you can choose to print some of this data, for example here. So first you print the name of the species. So let's say how to get that key. Okay, you can print the key. Okay, this will print everything otherwise. So let's not print the name of the species. If you want, you can do that, but let's try and just see how we are traversing and getting the likes and dislikes if you want to, right? So if you want k1 and k2, you can use another level of values, k1 and v1. So v dot items, right? So this also gives you k1 comma v1. Okay, this gives you the likes printed here and the dislikes printed here. Okay, so these are the likes and dislikes for all the three different categories or the species. Okay, so here you can just print one empty statement, so that this will be distinguished, right? There are three species, and for each of the species I could be able to find out likes and dislikes from this particular data, right? So just understand once again, I repeat, this D is not a dictionary, but it is a list which holds multiple dictionaries, and each dictionary also holds one more dictionary, and internal to that is the inner dictionary, and there is a list as well. So we can have any object inside any other object. Okay, rule is simple. List holds any type of data. Okay, it's a heterogeneous collection of data, and list holds since list can be formed using any type of data. We can use dictionary as an element to the list, and we also know that a dictionary can hold any type of object, right, into the key. So the key against foods key, we have another dictionary, and in that dictionary there is likes and dislikes is a key. We have lists inside this dictionary, right? So this is kind of a nested stuff we can use in the dictionaries, and that's why I just thought of sharing with this particular example. Okay, let's move on to the next data structure, that is set. Okay, so let me pull out our short notes here. I carry this, right? Yeah, here. Okay, let me copy this and we will use this. Okay, so here I'm going to introduce you with one more data structure called set. Okay, set, we will declare set using the curly brace. Again, it's same, right? But how it differentiate is dictionary is formed with the key and value pair. It is not with just a list of numbers or list of any objects, but it is the every value we store is having two things, right? One part of it is key and the other part is value, right? But whereas in set it is very similar to a list data structure. So that's why we can know we have a same way of declaring it, but the moment we write key and value pairs, it is treated as a dictionary. Okay, this is also a iterable object, this is also a non-indexed object, non-sequential object, and this is also a mutable object. Okay, but it holds only unique data. Okay, and no pairing here. Okay, no pairing means it just holds the values, right? I will take a simple example. Let's say s equal to I will take, let's say, okay, suppose this is how I have data, right? So very similar to list, but just that I have used a curly brace, and that makes interpreter to understand that we are trying to create a set out of these numbers, right? So, and look at the important aspect of this particular data structure, where you see so many elements in this particular set, but final a set has just few of them, right? The reason, if you see carefully and understand, the repeated values are not considered twice. Okay, unlike list, the list holds everything. Okay, but set holds only the unique data, right? And that makes that this is unique, and this is very useful for whenever you want to hold some unique information. So list is definitely good for many situations, and some situations you may want to hold only the unique data, and that time you can probably go ahead and use something called set. Okay, so the alternate option which we can think about is, let's say I have a list of these numbers, and I can very well print this and I have everything. But suppose I am interested in the unique values into a set, right, into this list. So we can just typecast the way we have done earlier, using list, using str, using int. So we can also use set to create a set from this iterable object, that is the list, and whatever values are repeated, those are not considered as part of this one. Okay, so that's how we create a set. There is also a provision to add something into a set, let's say 45, and I get the 45 added at this in this particular set. Remember, this is not appending, right? It just keep everything into a sorted order, and that's why you see that 45 is inserted somewhere based on the sequence here. Okay, so s1 dot add, there is also provision to add any other data type. It is not restricted to only use the numeric data. Okay, so let's try and explore other functions. Like update is one function, and let me see how update will do, right? Let us see, let me check what it does is update a set with the union of itself and others. Okay, so let me see, itself is s1, it's already there, and the other is I will go ahead and use, let's say, simple function, a simple iterable, that is list, and let's see what happens. Okay, so now s1 is having same data, okay, because 1, 3, 4 and 5, those are already there, so this is completely ignored. And suppose I have 15, and you see that 15 got added into this particular set. Okay, the set is getting updated with 15. Okay, because that is the new thing, right? Because otherwise the rest of the data is anyway already present. Okay, that's how we can use update. And the next thing is, let's try and iterate over this, right? For element in S1, and we will see how we print it. And look at this, we can print all the values in a set. Okay, so set is iterable object, correct? So s1 dot remove, remove is a functionality which we can use. Obviously what we want to remove is one thing we have to provide to the remove function. We can check the help page, I press shift tab and then I get the help page of the remove function, quick help here itself. So remove an element from a set, it must be a member, right? If the element is not a member, it will raise the exception, and that's okay. Okay, for example, I want to remove 5, so just 5. So s1 is now having all the elements but not 5 now, right? But s1 dot remove, if I say 55, so there is no 55, right? And that's where it gives error. Okay, sometimes it is good, but sometimes we want to silently delete if it exists, right? For that we have another function called discard. Okay, this is a useful function. For example, 15, if it exists, it delete. If it doesn't exist, it will not say anything, right? It won't throw an error. I delete 2 times cs1, right? Now there is no 15 because which is deleted, but now if I run once again, there is no harm, there is no side effect of running this function multiple times. Okay, even if you don't find, it's okay, it will just say that it doesn't return anything, it won't say any error exception, but it won't remove as well, right? If it finds, it will definitely go ahead and remove. Okay, so discard is sometimes a useful function, but there is also a pop function here. Okay, so check it, remove and return an arbitrary set element. So that means it not only removes, okay, it also returns. Okay, for example, here 5 was removed, but it has not returned, it is gone, then gone, right? So here there is a option, if you give 4, so takes no argument, yeah, sorry, I think I think it just removes 1. Okay, so without any argument, you can just keep on running this, and you will see one element is removed at a time, and that is returned. So obviously if it is returned, you can take it, you can make a backup of it, you can use it somewhere in other variable, but it just go ahead and randomly pop out of the set. Okay, so these are some of the functions we can use. We can also use some other functions, like we have, let's say we have 2 sets. Okay, I will take an example, let's say 1 2 3 4, and I will take another set with, let's say 4 5 6 7. Okay, so 4 is common here, remember. Okay, so here suppose s1 dot difference and s2, and look at this, what happens, right? This gives you the common the unique values in s1, right? The values which is not present in s2 is only printed, right? And if I run the same with little variation here, so instead of s1 dot difference, I do s2 dot difference and s1. So now the s2 is the set which is considered as the primary set, and it will check if any value is common between s2 and s1, then those values are not printed, otherwise it will just pull out everything from s2. Okay, so this kind of differences we may want to see, we may want to explore. So that is one of the option here, right? So alternative to see s1 and s2 are still same. Okay, 1 2 3 4 and 4 5 6 7. So s1 dot intersect, right? There is also a provision to get the intersect between these two. Okay, so remember the option what we have here is to find out the intersection between the two and the union between the two sets. Okay, this is set 1 and this is set 2. Okay, so you will be able to find out this section, or only the common values. You will also find out only the common values in this section, or only common values in this section. So these are some of the functions like difference, union, and the intersect. Union, I will just use it, union here, and s2 you will find out the union, all the values common, right, between them, between both. right? So that means this whole picture. Okay, so you will see that. Okay, yes, one. So these are some of the useful functions. Set is very useful at times when you want to keep the unique data and you don't want to you want to perform some of the differences, understand what is there and what is, the relative study with this couple of sets we can do. Okay, thanks for watching. This is all about dictionary and set. In the upcoming sessions, as and when we come across any situation, we will use these concepts and explore more about this concept. Go through each function of these two objects, dictionary and set. Then see you in the next session. Thank you.